So in example 6, it says we're going to use the square root property to solve a trig equation of the form u squared equals k. Like, for example, back in college algebra, if you were solving an equation that said x squared equals, I don't know, some constant, okay? You could get in there and solve for x by taking the square root of both sides and not forgetting the plus or minus symbol. So you would have x is equal to both positive and negative square root of 49, which is 7. Same idea here. So on example 6, the first thing we're going to do is isolate sine squared x. So first of all, we better add 1 to both sides. So we have 2 sine squared x equals positive 1. Now divide both sides by 2. So we now have sine squared x equals 1/2. Now we're ready to solve for our trig expression by taking the square root of both sides. And remember, when we do that, we don't forget the plus or minus symbol. Okay? Now, on the left-hand side, we just have sine x. On the right-hand side, we have both positive and negative. This is the same thing as the square root of 1 over the square root of 2, which is just 1 over the square root of 2. And maybe we should rationalize that denominator, okay? And so actually, we're going to end up getting square root of 2 over 2. Okay, so this plus and minus square root of 1/2 actually all simplifies to be both positive and negative square root of 2 over 2. Okay? Now, we actually have two different equations, one with the plus here and one with the minus. It might be a good idea for us to go ahead and split those apart. One equation will be sine x equals the positive square root of 2 over 2. The other one will be sine x equals negative square root of 2 over 2. Okay? Now, inverse sine both sides of this equation here. So for our solutions for x, we're looking for all of the angles that have a sine value of square root of 2 over 2. A positive square root of 2 over 2. That's going to happen in quadrant 1 for sine as well as quadrant 2. That's where sine is going to be a positive square root of 2 over 2. So, in quadrant 1, the angle that has a sine value of square root of 2 over 2 is going to be 45 degrees or pi over 4 radians. And again, we don't have to put the plus 2 in pi on there because of the directions in this problem. In quadrant 2, the angle that has a sine value of square root of 2 over 2 is 3 pi over 4. Okay? Now here on this one again, we're going to solve for x by taking the inverse sine of both sides of our equation. So our answers here for this next equation are going to be all the angles that have a sine value of negative square root of 2 over 2. Since this is a negative, sine is negative in quadrants 3 and 4. Okay, so we're going to have the angle that has a sine value of negative square root of 2 over 2 in quadrant 3 is going to be 5 pi over 4. And then in quadrant 4, 7 pi over 4. Those are actually our 4 answers. Our final answer is, and if they weren't already put in numerical order, we would want to do that. Okay, pi over 4, 3 pi over 4, next 5 pi over 4, and 7 pi over 4. Hey y'all, I know 7 pi over 4 is the same thing as just negative pi over 4. Can I give negative pi over 4 as my answer? Well, no, because negative pi over 4 isn't in this interval. It's less than 0. So I do need to give the 7 pi over 4 and make sure I do what is being asked in the problem. Okay? All our answers has to be in the interval from 0 to 2 pi. And all of these are.